Good afternoon, everyone. Today we will be discussing about the recent events, the Indonesian Ship Contest. This contest is one of the annual agendas regarding technological innovation in design, prototype, and performance in the field of shipping and maritime technology. The theme of this year's competition was offshore vessels. PENS, represented by its underwater robotic teams, participated in two divisions of the Indonesian Ship Contest. The first one was ISV, or Autonomous Surface Vessel, and the second was ERC, or Electronic Remote Control.
In this part, I'm gonna explain about the design of the ship in the ASV division. In the ASV division, the type of vessel developed is the Floating Production Storage and Offloading, or FPSO. This ASV ship is designed with a catamaran hull known for its exceptional stability, ensuring the vessel can maintain its position when facing external disturbances, such as wave and wind. The ship operates at a speed of 3 knots, weighs approximately 11 kilograms, and has a draft of 7 centimeters. It boasts a length of 75 centimeters, a width of 56 centimeters, and a height of 61 centimeters. These specifications are essential for the vessel's performance and reliability in challenging maritime conditions.
The component used on the ship will have a very important effect on the success of the mission during the race. The ISV ship will use two cameras. Camera 1 will be installed on the top of the ship and will be used to detect floating balls and capture images of the balls of the surface. Camera 2 will be installed on the underside of the vessel and will be used to capture image of the underwater box. Another supporting component is the LiDAR sensor to measure the distance between the ship and the box before capturing the image mission. The ISV ship will also be equipped with two underwater thruster motors as the main propulsion of the ship, so that it can maneuver according the race mission.
The ISV division arena is divided into two tracks, Track A and Track B, which mirror the other tracks. At the start, the vessel will be on the floating dock. Then it will move towards the green and red balls. The vessel must successfully pass through the center between the two balls without hitting either of them. The trajectory of the balls is in shape of the letter U with a zigzag position. After passing through the trajectory, the next challenge is to take picture of the box on the surface and underwater. After a successful shot, the vessel will return to the floating dock, which is marked with red and green colors. The mission is successful when the ship touches or hit the floating dock.
Next, we will explain the second division, the ERC division. In this division, the type of vessel that is being built is a platform supply vessel, or we can say it PSV. The ERC division vessel will use a U-shaped monohull hull type with an angle of less than 15 degrees, calculated from the center of the ship's section. The monohull type was chosen because it has several advantages, including efficiency in speed and thrust, good maneuverability, relatively simple construction, and good adaptability to different wave conditions. The ERC vessel has a hull length of 70 centimeters, a width of 24 centimeters, a height of 9 centimeters, and a weight of 3.4 kilograms.
There are a lot of components used in ERC vessel, so they can be divided into two groups, active components and passive components. The first one was active components. Active components are components that operate using electrical power and play a direct role in providing control and power to the ship. First, the brushless DC motor. This motor will provide the main power to drive the vessel. Second, the electronic speed controller or ESC. This component is used to regulate the speed of the motor and control the direction of rotation. Third, 2200 mAh battery. To power the motor, ESC, and all other electronic components. Fourth, the servo with a capacity of 25 kilograms is used to move the rudder for navigation and directional control. Fifth, transmitter and receivers to send and receive control signals from the remote control to the ESC. And the second was passive components. Passive components are components that don't use electrical power directly but provide stability, protection, and performance optimization of vessel. First, the cooling system to prevent the engine and ESC from overheating. Second, the hull, which is the main part that houses all the components and determines the stability and motion of the ship. Third, the propeller, which converts the power from the engine into forward motion in the water. Fourth, the rudder is a directional control device that functions to navigate the movement and the vessel according to the control of the servo. Fifth, the fin, useful for directional stability and to reduce slippage when turning at high speed. 6. The stinger or the drive shaft stinger connects the engine to the propeller and helps to optimize the angle and position of the propeller for the best performance of the vessel. 7th, the trim tab is used to stabilize the ship's position on the surface of the water, in particular to maintain the front and rear balance of the vessel when moving.
The mission of the ERC is actually quite simple. The platform supply vessel that has been designed will complete into races. In the first stage, the ship will travel along a prepared route without carrying a load. While in the second stage, the same vessels will carry a payload of 2 kilograms of iron or aluminum plates. Both races are limited to using only one battery with a maximum capacity of 2200 mAh and a maximum duration of 10 minutes.